Hello, welcome. You check. There we go. Welcome. Good morning, afternoon. How are we doing today?
Doing good. Can you hear me?
Yes, I can. I figure we'll go ahead and get started here in just a moment, but just gotta let it give people just a chance to join us if they're running a minute or two late, and then we'll get started.
Oh, so understandable.
Welcome.
Okay.
All right, 1 minute, and we will start. Quick little test on my end. There we go. All right. Without any further ado, let's begin. Welcome to our CCNA webinar here today. I'm glad to have you with us. Today, we're going to be talking about the latest version of CCNA. What is part of CCNA? What is the format of this exam? What is expected of us, and all the things in between there. Right? It is presently November 14th, 2025, and we are going to be talking about, I guess, version 200 dash 301. Somehow I got an extra one there in that, or an extra zero up there in that little note in the top right hand corner. Let me go ahead and fix that. 200-301. This is version 1.1 of CCNA. Naturally, CCNA changes over time. The test updates and evolves. It was last updated in around August of 2024. So, kind of settling into this current version here, having been here for a year. But nonetheless, yeah, we're talking about the version 1.1 version of the test, or 200-301 as it is also known. And yeah, let's dive right on in. Again, welcome. Glad to have you with us here today. Here are the basics of our webinar here today. We are going to talk about the importance of CCNA as it presently, is viewed by sort of the industry. We're going to talk about taking the exam, what's kind of involved there. We're going to talk about the test's format. I think any test that you take, you should kind of know how it's presented and what's expected of you. We'll do a couple examples of like questions just to get a feel for like, because there are different types of questions on the test, what to expect there. And then we'll talk about some different topics on the test. Once we get through those points, the floor will be open to questions. And yeah, that's what we got planned here for about the next 45 minutes or so. All right. The importance of CCNA. I mean, first and foremost, probably industry recognition. CCNA is well known. You know, a lot of people in the industry know about CCNA, to the point where even the HR department knows about it. So in a lot of places, it's going to be considered a requirement if you're going to be a network technician or a network admin or a junior network engineer or anything of the sort. So in short, CCNA's got some serious industry recognition, perhaps more so than really any other networking cert. It's one of the most widely recognized entry-level networking certs. And for good reason. This exam demonstrates strong understanding of like the fundamental concepts of networking. Like this isn't an exam that you can just sort of memorize some answers and then, kind of fake it till you make it per se. Like you really have to actually understand how these things work. You have to understand how IP addresses work, and that includes subnetting, which is, to some, and it's probably to many, quite a daunting thing, but like you got to really know how subnetting works and how that affects the network. You got to know how VLANs operate. What is a trunk? What is a native VLAN? What is 802.1q? How do those, affect the network, on the whole? And how do we use that to maybe reduce congestion on the network or improve security? We need to be able to understand how routers operate. How do they make decisions? I mean, in short, it's based off of IP addresses, but like, nothing is ever so simple. Like, how do they actually think? How does a router calculate the best path to reach a destination? How does a router determine where to send one message versus another? We need to understand how switches operate. I mean, some routers and switches are the same, but in truth, they're not. They're very different pieces of hardware. Their circuitry completely different. The circuits that make them up, night and day. You know, we use both in our networks, but being that they are very different pieces of equipment, we got to get a really good mind for how that thing actually operates and how to secure it and how to make it a more efficient part of the network. You want to talk about wireless switches? Well, then you got to also talk about Wi-Fi. How do we control the network? How do we automate the network? Software-defined networking included. I mean, there's a lot of really good fundamental things that are addressed here in CCNA. CCNA really, make sure that you understand those core concepts. And that's why it's so widely recognized and respected, right? Which helps lead us to better job opportunities, help us qualify for, I think I should say roles, not rules. Um, that's what I get for typing too quickly. But like help us qualify for different roles like a network technician, a junior network admin, you name it. Because again, if you got CCNA, that means that you understand the core concepts, you understand the basics, and you can be trusted, right? So it becomes like a requirement for a lot of those jobs. And it also is viewed in many cases too as a prereq for even more advanced things. So like maybe you've already got a job like, network admin. Maybe you're already a network engineer and somehow you manage to, get in there without having CCNA. But like to get that pay bump, you have to take, I don't know, CCNP. You need to take CCNP security. Maybe you need cyber ops. Like, well, CCNA helps with that. To take some of the more advanced classes or the more advanced certs like CCNA Enterprise here behind me, like CCNP security, like cyber ops, you have to have the understanding of the network in the first place. So a lot of people are going to say CCNA is a prereq for those. I mean, technically it isn't, but like it really kind of should be. Um, so yeah, CCNA, a pretty important cert, all things considered in the IT world. Are you with me so far? No, I mean, IT is not, I don't know. It's like somebody says they're a doctor. You're a doctor of what? There's a big difference between a doctor who specializes, let's say, in a brain surgeon versus a heart surgeon. They're very, very different jobs. They both involve like maybe helping people. They're both part of healthcare, but like, yeah, they're so incredibly different. But the same thing exists in IT, right? And one of our specialities, one of our big focuses is going to be networking. And I think really that journey into like, mastering networking starts here for most of us. Starts here in CCNA. Now, taking the exam. While this exam, is made by Cisco, as you would expect. Test was made by Cisco, test is maintained by Cisco. This is a Cisco certification. To actually take the test, though, you're going to go through an organization called Pearson View. Yeah, Pearson View. And Pearson View, in alongside Cisco, has decided that this test could in fact be taken at home. As in, if we're going to talk about taking the exam, we have to recognize there's kind of two ways to go about it. You can take the test at home, as in take it online, or you can take the test in person at a testing center. Right. So Pearson View is a company that provides exams like CCNA, like Security Plus, if you've heard of that one. Pearson View provides a lot of different IT certs. Not all IT certs can be taken at home, but certainly this one can be. I do have to give you a little word of warning, though. If you are going to take a test at home, be sure to read all of the rules and conditions during the sign up process. There are a lot of rules about taking the test at home, and I've certainly had more than a few occasions where perhaps a CCNA student did not really read all the rules and conditions, or glossed over them, scrolled through them. We've all done it at least once. See a big old contract in front of you, I'm not going to read this. Um, and then kind of later had a bad time because of it. In short, basically, if you don't follow the rules, they'll fail you like that. There's a bunch of rules about how you have to take a test at home, and they're pretty strict. They're pretty strict. So if you are going to take it home, make sure you know all the rules and conditions. Having said that, though, the test that you would take at a testing center and the in-person test and the at-home test are no different. No different at all. Like it's not like, oh, I take the test at home because it's easier, or I'll take the test in person at a testing center because it's somehow different. No, it's not. It's the exact same test, whether you be at home or in person. Like test is all the same, but there's just a lot more rules about taking it home. Why? Two reasons. They don't want people to cheat, which is pretty reasonable, right? Pretty reasonable, all things considered. And they want to make sure people aren't stealing test questions and so forth and, like, I don't know, selling them or something. So they got some rules. Make sure you understand those rules. To that end, this is like something I think is really, even if I teach a CCNA class, I'll kind of bring this up in like the first half hour. When you take the test, almost everybody ends up making what is called a subnetting chart. Right? I mentioned a second ago, subnetting, breaking the network up into parts by basically manipulating subnet masks and thereby IP addresses, um, is a part of the exam. It's a critical part of basically domains 1 and 3, which we're going to outline here shortly. And I don't really think you can get through this test without it. But it's math. Who wants to do a lot of math in their head? Nobody. Nobody wants to do a bunch of math. So to that end, what I normally bring up at the beginning of like any good class is that you probably want to be making what's called a subnetting chart, a little diagram of sorts that explains, you know, what is the binary value of this and what the mask of that is and what's a CIDR notation, and this little chart that kind of really helps you do the math faster, do the math easier without doing less of it in your head. You just build this chart out at the beginning of the exam, and then you can reference it throughout the test. I mean, come on. Who would want to do that? I can do most of the subnetting math in my head because I've been in the networking world or doing things with IP addresses for, good God, probably almost 28, 29, almost 30 years at this point. So, like, you know, now I wouldn't say I mastered subnetting on day one. I don't think anybody really has, but like over the course of years, I've gotten really good at subnetting. I can do most of it in my head, but like, I still don't want to do that during a test if I can avoid it. Um, the pressure's on during a test. Who's ever had some test anxiety? I think everybody has test anxiety, or maybe you wake up one day and you're just not all there. You don't want to have to think any harder than you should, and you rely on the chart. This brings me back though to that whole testing at home thing. I think having a good subnetting chart is a pretty good important part of this test, and having a place to do some math, maybe on some scratch paper, is a pretty important thing. Um, but if you take the test at home, you don't get any scratch paper. So, like, when the exam begins, you're allowed to perform a brain dump of everything in your short-term memory when the exam begins. See, this test is not open book. This is not an open book test. You don't have access to the internet. You won't have a phone. You don't have a calculator. You're not allowed any resources whatsoever. But you are allowed to brain dump things that would be in your short-term memory at the start of the test. Like if you want to make some notes, you can do that. And if you want to make a chart, a subnetting chart, you can do that. You know, like if I want to, the start of the test, start drawing out a chart, I'm allowed. Start writing out a chart 128, 64, 32, 16, 8, 4, 2, 1. I'm building my chart. It's going to help me with my math later. If you are taking the test in person, right? Taking the test in person, you get a dry erase board. They give you like an 8.5 by 17 piece of like legal sized grid paper that's been laminated. They give you a dry erase marker. You can make your chart there by hand. If you decide to take the exam online, however, you're taking it from home, the most you get is what is called the whiteboard feature in their software. This is basically Notepad. Like, you get like a Notepad document that you can, put stuff in. But that's not quite the same as being able to actually write things down, is it? So, you know, kind of step number one, I really do think, as you prepare for this exam, is to figure out in what condition will you be taking it. If you are planning to take it at a testing center, because perhaps you have a testing center near you, in a reasonable distance that you can drive to, well, then get used to writing things out by hand and doing all of your math on paper and practicing by writing things down. Meanwhile, if you are taking the test at home, you know, and because the testing center isn't nearby, well, then you're going to be making, charts and notes and doing math all inside of their whiteboard, basically inside of a notepad document. Because you don't have access to anything else during the test. Like during the test, they lock your computer down. You don't have anything access to anything else. So you have to take notes in this capacity. No note taking by hand or any paper or anything on your desk is like permitted whatsoever. So um, yeah, this test is provided through Pearson VUE. Tests can be taken in person at a testing center or online. But if you take the test online, the rules are a little different in the sense of you can't have any scratch paper. You have to use your notepad document, which for many of us just affects kind of how we're starting the test, and how we're engaging with the test, and how we're going to go about making a subnetting chart, which takes a lot of the edge off of some of the math. It's not a crazy math test. It's not like everything's math. We're not like solving for X. We're not doing algebra here. But like there is a little bit of, here and there of math happening, some binary math and so forth. Having the chart certainly helps. With that said, the test's format itself, right? The test is 2 hours long, 120 minutes. And the test is provided in English or Japanese. There's no support for other languages at the moment, just English and Japanese. Those are your two options. If you, in advance, make accommodations, sometimes they will give you extra time, assuming you can prove that English and or Japanese is not your native language. It's like, all right, well, I didn't grow up with either of those languages. Those are not my native languages. They may give you some more time. But that all has to be arranged in advance before you even schedule your test. Don't show up to the testing center and be like, "Hey, can I get some more time?" At that point, they can't do nothing for you. For most people, though, I assume they're just going with the standard, 120 minutes, 2 hours. Now, the results of this test are purely pass-fail, meaning they do not show you a score. There are other tests where they show scores at the end, but not this one. It is all just pass or fail. No score is shown. That is in contrast to an older state of this test. If we were to turn the clock back about 3 years ago, they would have shown you a score, but they don't anymore. Having said that, the estimated requirement for passing, even though they won't show you, is about an 825 out of 1,000. Right? Most of these tests are graded off of a 1,000-point base. You got 1,000 points you can get. Here you need to get about an 825, out of 1,000 in order to pass. Now, having said that, though, you might interpret that as, okay, if there's about 100 questions on the test and every question thereby is probably worth about 10 points, I need to get like 83 questions out of 100 correct. Something like that. Yeah, quite. I think that's part of the reason they don't even bother showing scores anymore. Some questions are worth more than others. You can have one question that's worth 50 points and one that's worth 2. Not all questions are weighted evenly. Some questions are partial credit, some are not. I would assume most are partial credit. But again, one part of that partial credit might be worth more than another. So, it sort of leaves people at this weird point that is like, the score doesn't necessarily tell you as much as you would think. And also there's been this bad practice over the years of people saying, well, I got an 830 and you got an 829 and thereby I'm better than you. And that's not really true because not everybody takes the same exam. Everybody will get different questions, different simulations, different performance-based questions and so forth. So like comparing one score to another really doesn't even make sense anyway. So for that reason, and I'm sure probably many more, we're just not going to show scores. No scores are actually shown. It's all pass or fail. No scores are shown. But the estimate is you need about an 825 out of 1,000, even though they're not going to show that to you. Having said that, when you do pass a test, be it fail or pass, either way, they do give you little progress bars. You see, the test is broken up into 6 sections. Now, it doesn't not go from like section 1 to 2 to 3 to 4 to 5 to 6. No, but like there are like effectively 6 different categories of questions within the test. We're going to look at those here shortly. And they give you little progress bars for each of those sections. So if you were not to pass, you sort of look at whatever section has the smallest progress bar. It says this section you only got 22% correct and the progress bar is not very full. That's the section we're studying. So you're not completely at a loss at the end of the test, but don't be expecting a point score, all right? Question count 80 to 100. Most people are trending around like 85, 90, but theoretically could go up to 100. What I'm thinking is the lower the total number of questions, and they do tell you at the start of the test, they'll tell you how many questions at the very beginning of the test to expect. Your test has 83 questions or your test has 87 questions. The fewer questions you have, the more performance-based questions you get. As in to say, there are different types of questions on the exam, right? Kind of 3 different categories or types of questions. There are performance-based questions. People like to call these PBQs. I like to call them simulations. They give you a simulated environment where you have to perform some actions, configure a router, configure a switch, configure this, configure that. Do this, do that. Real hands-on kind of stuff, which is cool. And unlike some other exams that might have simulations, wherein like they give you a command prompt, there's only 2 commands you can actually use. For the most part, this test will give you full access to all the commands that would exist on an actual Cisco router or switch. They give you all the tools. Um, which is neat. So like real hands-on stuff. These performance-based questions used to show up randomly throughout the test. Just pop up randomly. But as of like the last 6 months, they've been showing up at the very beginning of the exam. The first couple questions you get will be performance-based questions, as it presently is here on you know, November 14th, 2025. What they do a year from now, 6 months from now, 5 years from now, I know not. But they constantly changing format of the exam. The exam's changed its format about 5 times in the last 4 years. But like at the moment, they're all at the beginning. And they involve many steps. Configure this router, then configure the switch, then do this, then do that, then do this. Like multiple tasks will be given to you. Usually there's about somewhere between 5 to 15 things you sort of have to do as part of setting something up or troubleshooting something. All partial credit though. Because that's like question number one could be one of these simulations and it has like maybe let's say 10 parts to it. That's basically 10 questions on number one. And again, partial credit. To that end, if you had, let's say, 3 simulations, you're probably not looking at 100 questions. You're probably looking at like 75 questions, 80 questions tops. You know what I mean? Because like those first couple simulations just take up a lot of your points. That does bring up an interesting point, though. If the simulations are worth a good number of points, and I would estimate it's got to be at least like 200, you know? They don't tell you how much each question's worth, and again, some questions are worth more than others. But like, if the sims are like 200 points, that does suggest that if you skip them, there's probably no way to pass the exam. Like, you have to do them. Like, even if you can't do all of it, you have to do some of it. You know what I mean? Can't skip them outright. I've heard of people doing that sort of as a point of fear or panic, like, oh God, I don't know what to do. And they just skip, skip, skip and go right to the multiple choice part of the test, which comes later. Then at that point, I think we're kind of already done before we've started. So Sims are worth quite a bit here, right at the beginning of the test, performance-based questions. After that, there's some multiple choices and drag and drops that are sort of just all mixed together. I would expect, all in all, again, the Sims are probably worth about 200 points. There's probably You're going to probably get 2 to 4 of them on average. Then you got multiple choice, and that's probably about 65 to 75 questions, multiple choice questions. Some of which are your classic pick one from A, B, C, D. Some are pick twos, some are pick threes. But I think we all know what a multiple choice question looks like. And then drag and drops, there's probably 5 or so of those floating around somewhere. Match these terms to definitions. Here are problems, here are solutions, match them, that kind of stuff. They're pretty easy, all things considered. I really do appreciate drag and drops. I think usually less convoluted than some of the multiple choice questions are. But I'm sure there's a few challenging ones in there somewhere. So all in all, to recap this, the test is 120 minutes, 2 hours, presented in English or Japanese. The results are purely pass-fail. They will not be showing scores, but they do kind of show progress bars for the different sections of the test. You're expecting somewhere between 80 to 100 questions, wherein the simulations, the performance-based questions, will show up at the very beginning of the test, at least as it presently stands, and are worth more on average than a single question. Once you get past your performance-based questions, you will be in the back part of the test, or the back half, I consider it, which is all multiple choice and occasionally a drag and drop for fun and variety's sake. Let me know if there are any questions about test format. Incidentally, at present, the test is forwards only, by the way. There is no back button, and thereby no way to flag questions or bookmark questions for review. It's forward, 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 the end. So if you're on question 81 out of 81 and you hit next, that's the end of the test. No going back. You'll need to pace yourself carefully. You want to make sure you don't spend like an hour on your simulations and then leave 1 hour for the other part of the test. Figure about 10 to 15 minutes for each simulation is the most you get, and then on your way. But pacing here is a tricky thing. Don't want to spend a half hour on a single multiple choice. Don't want to spend an hour on a single simulation. One should pace themselves accordingly and recognize that they can't go back. I wanted to give a little example of what like the performance-based questions might kind of be, and like what is kind of the vibe here. Again, these pop up at the beginning of the test. They're multiple choice, or not multiple choice. They're multiple. They involve multiple tasks, multiple things you have to do, and they sort of bullet point them out or list them all out. And they give you a topology, a diagram where you can click on the devices to access like their control panels or access their command lines and actually perform the tasks they've given, right? But like here I see two tasks on the left. I see task 1 and task 2, and effectively 3 bullet points. There's 2 objectives for task number 1 and 1 objective for task number 2. I have to imagine it's probably like, I don't know, this is 15 points, that's 15 points, and this is 15 points. There's like basically 3 things in truth here they're asking us to do. It would appear that the first 2 tasks are all related to DHCP and addresses being handed out as part of dynamic host configuration protocol. And then the bottom thing has to deal with static routing. So kind of 2 different exam topics are being dealt with here at the moment. Part of domain 3 and part of domain 4. But like, if you get the first bullet point right, you get points for that. And then if you get the other ones wrong, hey, at least you got points for the first one. So all partial credit here. But like looking at this, it says what? Task number 1, configure router number 1. That's this guy. As a DHCP server for the 10.0.0/24 network. Right. So like in order to do that, you would need to go to router number 1, click on it, and in doing so, it would bring up some sort of a command prompt for router number 1. Right. And then be able to go through the process of doing so. You type in enable, you get in a global config mode by typing in config terminal or conf t for short. Once you're in global config mode, you can create your DHCP pool and give it a name, tell it the range of addresses or the scope of addresses it's allowed to give out. Here they wanted what? The 10.0.0/24 network, right? So we like make sure that gets put in there accordingly. And we perform all those actions, we back on out of that, probably save our work, copy, run, start. Usually saving your work is viewed as a good move. But like, all right, go through the process of completing this objective. Once you feel like you've done that, what I like to do is I like to look at the task, go back and look at my config and make sure they all line up. Does that make sense? Did I typo anything? If it all looks good, then on to the next bullet point. You just sort of work your way down the list. Step number 2, I would go to router 3. And what does it say? So router 3's gig 01 interface needs to be set as a DHCP client, allow it to get an address through router 2. So that's actually a 2-part process. If I rewind here, you got to go into router 3 and set it to be a client, but you've also got to go to router 2 and set it as what we call a relay. Yeah, DHCP relay is what you have to set up there, and technically on this gig 01 port, which is closest to router 3. That's one of the cool things you like learn about in the CCNA class, right? What are the limitations of DHCP? How does DHCP work? What is the DORA handshake you may have heard of relating to DHCP, the dynamic host configuration protocol that hands out IP addresses to the network? Like, how does that work? And what are its limitations? And then what is the difference between a DHCP server and a DHCP client and a DHCP relay? And then ultimately why you need a relay in this particular instance. So it turns out DHCP messages are broadcasts, and broadcasts do not pass through routers. So to make sure the messages can get through this other router, router 2 has to be set up as a relay so it can relay the messages back to the original router number one, the server from the top task. But like, oh, okay, so there's a two-part thing going on here for the second bullet point of task number one. So you have to go to router two, you have to go to router three, configure them accordingly. Task number two has only one bullet point. It says write a static route on router number two, this guy here, that would allow it to reach the network connected to router three's gig02 interface. So you basically teach router two how to reach the network over yonder that is not directly connected to. So be using the command, IP route, the destination network, followed by the next hop in all likelihood. But like, okay, you complete all your tasks as best you can. Some you might not be able to. Maybe you forget a command. Happens to the best of us. And you try to spend no more than like 10 minutes here. But all in all, typing them out, doing what you can, trying to configure things. And this is that really cool hands-on element, in a sense, that you don't really see as well illustrated in necessarily other exams. So PBQs, our simulations, our performance-based questions are really good, really cool part of this exam. And they don't really care how you go about necessarily completing these objectives as long as you complete them, which is pretty neat. Right? But cool. That comes at the beginning of the test. Right? Then after that, it's all multiple choice and drag and drops. Like, which of these two conditions would prevent a pair of OSPF routers from forming a neighbor adjacency? Select two. You read the answers, do a little process elimination in some cases, narrow it down to what seems like the most likely cases. Here would be the OSPF timers are mismatched. See, OSPF is a system that allows routers to communicate. Allows one router to tell another router what they see. And so it turns out that routers can only see things that they are connected to by default. Kind of paint a picture here. We'll call this network number one. Here's a router we'll call A. Here's network two. Here's a router we'll call B. And then over here is network three, right? Network one, two, three, with router A and B there in the middle. Router A, router alpha, can see both of these networks, one and two. But it can't see network three because it's not connected to it. Again, by default, routers can only see that which they are connected to. Because router A doesn't know about network three, router A can't send to network three because it can't see it. Doesn't know it's there. How do you get to a place you don't know exists? You can't. Right? So we use static routes sometimes to teach one router how to reach places it's not directly connected to. Or we use something called OSPF, the open shortest path first routing protocol, to allow the routers to tell each other that which they cannot see. Like with OSPF turned on, router B can tell router A, hey man, I got a 3 network over here. You ever need to get there? Send to me, I'm your guy. Vice versa, router A could tell router B about network number 1 that router B doesn't know exists. And that's pretty cool. But like, in order for routers that have OSPF running on them, like as a program, in order for them to communicate, they need to be neighbors. And in order for them to communicate and share their tables and their information further, they usually need to achieve what's called an adjacency. One of the things we learn in class is that it seems like that would automatically happen every time by default, without problem, without issue. And yet we'll find occasions in networks where that won't pan out, where because of maybe mismatched timers, which is kind of the most likely culprit all the time, our answer A, router A and router B refuse to communicate. Their timers, their hello timer, their dead timers do not match, and A goes, oh, well, I don't want to talk to that guy, and vice versa. So A and B won't communicate because they won't talk. They can't learn about things that aren't connected, and well, then your network doesn't function properly. So A is by far the most likely thing, but there is one more, right? There's the pick two. Want to make sure we get both of our answers for the most points we could possibly get here. B would not cause this problem specifically. B causes other problems. Failure to pass the XStart or exchange state, but does not affect the ability to neighbor. So that's out. Another thing we would discuss thoroughly in class. Routers have different descriptions on their interfaces, basically, is how I read Charlie. Nope, that has no effect on this at all. You can, like, on any port on a router, give it a description, give it a title, give it a name. This is the port that connects to Matt's computer. This is the port that connects to Bob's computer, etc. That has no effect on this. The interfaces are configured as passive interfaces, basically meaning they were put to sleep. Yeah, that'd do it. Passive interfaces will not communicate. And then echo, the router IDs do not match. Yeah, if they did match, that would be a problem. They have to be different. But yeah, there you go. So like A and D, next question. This is an example of multiple choice. Of course, another example of questions is drag and drops, right? Like they'll give you some definitions, they'll give you some terms, you got to match things up. An EGP, an exterior gateway protocol that shares routes to other autonomous systems, that's a description of BGP, the border gateway protocol. Right? An IGP that uses Bellman-Ford to calculate the best path based off of hops, if you know about that one, that's RIP. An advanced distance vector protocol that uses the dual algorithm, oh, that must be EIGRP. And that which remains, however improbable, must be truth. I guess that's OSPF. But drag and drops are another thing you'll find within the exam. So, one of our last topics here to talk about before we wrap it up, and also we open the floor to questions, of course. Exam is broken up into 6 different sections or domains, as it were. Yeah, you can read more about this in great detail here. I'm going to share a link to chat on Cisco's website. That is learningnetwork.cisco.com/s/ccna-exam-topics. On that website, I just linked here in chat. You can kind of read more. Some of this is stuff I've already said about the different formats of this exam. But like all in all, you can see what are the different sections of this exam. And here we see that section number 1, known as Network Fundamentals. Network Fundamentals is 20% of the test. So 20% of your questions and 20% of your points coming from there. Network access is also 20%. IP connectivity is 25%. That's about routers and IP addresses and all that fun stuff. IP services, DHCP, DNS, logs, and stuff like that, that's about 10%. Security fundamentals is 15%. That's like basic security stuff, how to secure your network, how to set passwords and stuff like that. And then automation and programmability, or software-defined networking, and how to control your network through software is the last 10. Thereby, I guess, the real heart of the exam is kind of these first 3 sections, sections 1, 2, and 3, which by far have the most objectives and sort of bullet points in them. But yeah, these are the 6 different sections of the exam. We're going to take a quick walk through those. I'm going to kind of paraphrase the topics that are part of this. Again, through that link that I shared in chat, you can see a more detailed breakdown of what is part of like each of these sections. Like here in Network Fundamentals, it says, explain the role and functions of network components. It lists out a bunch of different components. This means you have to know what those things do. But yeah, I'll paraphrase it, keep it simple, and just keep it short and easy for the moment. That network fundamentals, that first 20%, you got to be able to explain what routers are, what are switches, what are firewalls, what are access points, what are endpoints, what are servers, what are controllers, what do they do? What do they do? Not a hard topic, all things considered. Have to understand different types of network architectures. What is a 2-tiered network, a 3-tiered network, a spine and leaf network? We compare different types of cabling, fiber versus Ethernet. We identify different types of interfaces like ports that you could be plugging into, RJ45 versus ST ports and so forth. We also talk a lot about cabling issues. I guess it's so important to like understand the physical side of things. Yeah, if the cable doesn't work, nothing will. No amount of configuration can save you from a bad cable. So definitely start there. We talk about the differences between TCP and UDP, which is pretty important to layer 4 of our OSI model. What is the difference between the, transmission control protocol and the user datagram protocol, and how do they affect the network's performance? We get into IP addressing, including subnetting, but it might make you think that subnetting is only in this section. It's in others as well. Subnetting kind of makes its way through multiple different sections of this test. So again, pretty important. It's usually like a big part of day one of any good CCNA class. Really locking down how subnetting works. But like, all right, how does subnetting work? How do IP addresses work? Including how do IPv6 addresses work? And then we talk a little bit about wireless concepts and virtualization and how that relates to the cloud. That's kind of all our fundamentals section. By the way, for those not aware, this little icon here, this cylinder with some arrows on top, that's the network icon or the icon in like a diagram for a router. In our second section, which is also 20% of the test, we talk about network access. This is a chapter heavily focused on switches instead of routers, and thereby focuses on things like MAC addresses and VLANs and trunks and neighbor discovery protocols like the Cisco discovery protocol versus the link layer discovery protocol. We also talk about how to set up ether channels and how to set up spanning tree. And then we kind of move away from the, I guess, more physical equipment and cabling and how to configure the switches to maybe the wireless side. We talk about Cisco wireless architectures and the different types of wireless access point modes that exist and what they do and how they function. We also get into a little bit about how to manage devices, like remotely through Telnet or SSH or HTTP, and some guidelines on how to do that safely, which will be reiterated ultimately in the security fundamentals chapter as well. Like these are all really good things that somebody, who's a network engineer or, network manager, you name it, network admin would all need to know. IP connectivity. Interpret the components of the routing table. So back to routing stuff, back to IP addresses. How do routers make decisions? And if we spent basically the second section talking a lot about how switches operate and how switches function and how they think and how they connect devices inside a network together, we got to talk a little bit about how routers connect different networks together, and how their routing tables work and how the router thinks and how to configure static routes and how to configure OSPF. Yeah, there are other routing protocols, right? I mentioned a few a moment ago in that drag and drop, RIP, BGP, EIGRP. We really focus though here in CCNA on OSPF, the most commonly used one. You get to CCNP, you can look at the other ones. We also talk a little bit about the first hop redundancy protocols, the idea of having multiple routers running simultaneously, all connecting you to the internet, some of them being backups if your main router fails. How to configure that, how does that work? Pretty cool topic. Also notably, this is the biggest section of the test, 25%. And subnetting making up a good, like manifesting itself in a good amount of the configurations that need to be done here. So more subnetting, of course. IP services. Now we're getting to the back part, we're getting into the weeds a little bit. This is only 10% of the test. Configure and verify the inside source network address translation using static and pool. So basically how to do address translation from private addresses in a private network to public addresses, the internet. How to set up network time protocol. How to configure like DHCP and DNS and what do they do and what is SNMP and what is syslog and what is quality of service or QoS. You learn how those work and how they're configured. We can figure out how to configure the DHCP client and relay hinted at earlier in our simulation, like how to set up what's called a relay and why you need one. We configure devices for remote access using SSH. We learn how to set up SSH, the secure shell, to remotely and securely access things. How to make the crypto keys and generate them. We also talk about like what is the trivial file transfer protocol and the file transfer protocol, which mostly I guess kind of really gets into how to properly back things up. How do you back up your network? How do you back up the configurations of your devices? But all that's part of this small section. Security fundamentals is 15% of the test. We talk about like the difference between threats and vulnerabilities and exploits and 0 days and different types of malware a little bit. I find that a good chunk of the security fundamentals, like a good quarter of this section, is just terminology and good definitions so that you can, have a conversation with like a security team and not look crazy. We configure access controls. We learn how to set passwords on the equipment. We talk about VPNs and IPsec, the Internet Protocol Security. We talk a lot about access control lists and how they can be used to filter different types of traffic on the network. How would you block telnet and permit SSH? How would you block a ping or permit a ping from crossing the network? That's pretty cool. That's a good topic. We configure tools like DHCP snooping. We learn how to configure port security. Again, as a note, this is sort of a condensed list. It's not the end-all, be-all, exhaustive list. This is me summarizing the big key points here, though, of security fundamentals. We talk about the difference between authentication, authorization, and accounting. Three concepts together known as AAA. But like, how are they different? And what do they do for us? How do they help us secure the network? And we even get into a little bit of Wi-Fi security with Wi-Fi protected access 1, 2, and 3. Pretty cool section. The very last section, only 10%, is really about automation. It's about how the world has evolved, really. We used to control the network through what was called traditional management, one device at a time. You configure one device, then go configure another, so forth and so on. It was a lot of work. And if you misconfigured one thing, the whole thing stopped working well. Typos or a little mistake here or there could really brick the whole network. We decided it was better to take a controller-based approach, have like a Cisco Catalyst server, also known as the DNA Center once upon a time, as part of this more grandiose concept known as software-defined networking. Have this one server that uses software to configure the network for you like that, and in a very reliable fashion. Configure lots of devices from one place. And this really impacts how we manage the network today. We're working smarter, not harder. We're configuring lots of things from one place. And here in this section, we talk about how that would work. We talk about what is the North API and how that interprets programs and feeds them to the server. And then the southbound API, which allows the server to control your routers and your switches, update your equipment. We talk about how that all works. Within this chapter is also a little bit of talk about AI, how AI might be also used to control your network and update your network for you, which is pretty neat. Pretty small chapter, all things considered, or pretty small section of the test, but a cool one nonetheless. So those are kind of the key elements here of CCNA as it presently stands, with a little bit of talk to test format. So hopefully you have a little bit better of a feel for what is or isn't part of the test. And if you don't, well, hey, the floor's open for questions. Roger that, Eric. Take care, man. Be safe out there. So, anything worth discussing, folks? Well, I plan to hang around for a few minutes if there's anything at all I can answer or you want to talk about. Otherwise, I say it was a pleasure having you with us here today. I hope this webinar helped provide some clarity regarding the CCNA exam, how it's presented, what's part of it, its importance relative to the world today. I hope to see you in a class sometime. That'd be cool. Right on, Raymond. Got to get back to work. Roger that. I'm glad to have helped. Been part of your journey. Have a great day and a great weekend, I hope. Yeah, happy Friday. Good day of the week. All right, Virgil, I'm going to start powering stuff down, but all in all, uh, I hope your notes here from Fireflies is useful, and you're able to, you know, get some value out of our webinar here today. Take care and be well.